Hello and welcome to our second session of this year's Roundtables Europe, here broadcast live from a studio in Berlin. My name is Marian Willuhn, I'm an editor with PV Magazine, and I'm going to moderate you through the next hour of this year's Roundtables. Over the next hour, here on the stage, we will address a critical topic that has been on the forefront of discussions in the solar industry. It is the quality of TOPCon. The shift from PERC cells to TOPCon technology has undeniably been a significant move in terms of efficiency, in terms of bifaciality, in terms of the temperature coefficient that these new cells provide. But it has not come without any challenges. Quality issues have surfaced. A report from a research institute that was published in June has rung the alarm bells and spread uncertainty. Do the warnings address all TOPCon modules in general, or is there more nuanced story behind this? We're bringing the debate here on this stage, and we will find out. First, we will hear from Jinko Solar, how they have introduced and embraced the TOPCon technology, and crucially, how they ensure the quality of their manufacturing processes and to what length the manufacturer goes to. Then we will be joined by an early adopter of TOPCon as early as 2020, the German module maker Solyco. The company has made the shift to TOPCon, and we will hear firsthand how they have addressed quality concerns. And then our event doesn't stop there. We will host a panel of experts going right into the heart of the matter. The panel comprises Sandra Lust of PI Berlin, Jörg Althaus from CEA, Jean-Nicolas Jaubert from PVEL, and Christos Monokroussos of TÜV Rheinland. So be excited for that. Thank you for joining today and welcome to this conversation. We will now start with our first guest. It is my pleasure to invite to the stage our first expert of this session. Our speaker has been part of Jinko Solar for 3 years, contributing to the company's technical product design, and armed with a bachelor's degree in electrical engineering and a master's degree in renewable energies, my guest boasts a robust academic background. And her experience extends beyond Jinko Solar, including roles as planning analyst at the National Electricity Corporation and as a member of a solar team at TÜV Rheinland. Please welcome with me Johanna Bonilla, the technical product manager at Jinko Solar. Hello, Johanna. Welcome to our Roundtables Europe.
Morning. Thank you for the invitation. I'm super happy to be here discussing this hot topic, TOPCon. And on behalf of Jinko, thanks for the invitation. I'm glad to share also my presentation today. And you tell me when I can start.
Oh, you can start now.
Oh, great, perfect. So for today's presentation, I have a comprehensive one, but I will try to keep it short and leave more time for discussions. So first of all, of course, mentioning Jinko has a global module manufacturer with a strong deployment of TOPCon. We have a capacity of 150 gigawatts delivered, but a capacity of 5 gigawatts in TOPCon. More of the 50% of our model capacity is dedicated to this technology to show how much we trust our technology. So several records, and I will discuss those in the next slide. So let's jump on it. So as I say, we have deployed most of our TOPCon since 2022 with the strongest portfolio of the market. And our records is something that we would like to mention also as part of the presentation, not before saying that Jinko have a vertical integrate production. So the deployment of TOPCon and the challenges go for us from the ingot to the wafer, to the cell, and to the module. So let's move on because we have to present why we are strongly trusting in this technology. And first of all is our investment in research and development, our worldwide records. We have been working in TOPCon since 2017. Most of our records of these 25 records are based on TOPCon technology. And recently we also moved to tandem TOPCon. So beyond all this deployment and the mass production is a strong R&D. And this is basically the focus of this presentation. So for Jinko, it's very clear the technology background and why TOPCon. So there are theoretical limits. So first of all, understanding the boundaries of the solar cell technology, what is the feasibility and the potential breakthroughs of this technology, the mass production viability, of course, we need to understand what is from this theoretical advancement, what could be achieved and maintained at the scale that Jinko produce, maturity and compatibility, not to mention that most of the processes of production comes from PERC and could be adapted to TOPCon. Of course, this is business also. We need to take into consideration the cost. The supply chain has to be robust and reliable for the product that we launch, and also maximizing the operational efficiency. Part of our decision is also the market. Is the market ready for this technology? It's ready. What is the push of the market? What is the need? And of course, the regulatory landscape. So with that background, Jinko has chosen TOPCon with different theoretical ultimate efficiencies compared to the current, let's say, technologies that we see in the market, with some advantages at certain processes like delamination, for example. We have less delamination risk, less moisture sensitive. So this technology understanding has triggered our decision, but also our experience. And we have a clear development trend. So what you can see here is our expected mass production, cell efficiency. So we are clear in our path and also in the steps that we need to do to achieve this 27 or more than the 26 that we are already moving towards next year. So our path is clear based on those technology understanding. And recently we move and we boost also our power cell efficiency conversion, and this is also important because behind every new decision that you will see from Jinko, there is already a strong technical and a strong research and development background. So this is just the latest record that we have in combination with TOPCon and perovskite. So Jinko is always from the R&D moving forward and from the mass production, let's say, moving with maturity steps. So what are the challenges in the production? Because this is what we like to discuss today. So since we are a integrated, vertically integrated production, we experience challenges at several levels. This is one example for instance, for the wafer. So the wafer, actually, the biggest, the challenge, the more challenges that it becomes. So first of all, there is a uniform ground when we actually have an ingot and the interface, the grow interface has a uniform resistivity. The problem comes when we cut the ingot. So the vertical cutting will have an impact and actually will introduce different resistivity. So this is a fact. The larger the wafer, the larger the difference. So more larger, let's say, ingots will have to take care into consideration other processes and other control of quality. The good news is that M-type have a better uniformity than P-type, and this is what we show in the graph at the right, where the distribution of the radial resistivity variation is better for M-type compared to P-type. So challenges are many at the cell level. I think one of the concerns that we have heard is the wrap around of the positive polysilicon removal, and for that you can rest assured that Jinko have invested also research and efforts on developing their own technique. Here there's a picture of the cell before and after the wrap around from Jinko Solar. So we ensure a complete, let's say, uniformity of this process during our cell production process. I just brought some of the problems that we have, or some of the challenges that we have. At the module level, choosing the encapsulant has become also a challenge. So here there are many new, let's say, technologies. We can use EVI, we can use POE, The question is what to use when, and when this product or this technology is suitable for the modules. So what we do is actually evaluate different scenarios, and I heard the introduction about concerns, especially on the metallization and damp heat being one of the, let's say, more intense steps to prove this reliability. So what we do here is to compare different combinations. Here we have results for a monofacial, actually not on no bifacial, monofacial module, which is most of the concern actually related to monofacial, where we can see that the combination of POE and EVA or double POE or POE encapsulation has actually an average lower than the specification of the standard in our testing. So this is result of several modules of units of testing. So our message here is always Jinko considers the implementation at the mass production, the quality that we will keep at the mass production, the supply chain, of course, but also the reliability. So our modules experience also different testing and different results. And I think one of the biggest challenge that Jinko has experienced being the leading of this technology is also education in terms of what is different for paired and from technologies of the past. So this is one example, and it's called the electroluminescence ring. So we can see something that is similar to concentric rings that we saw in PERC, with a different message. So this is something that we are quite sure that this effect is not related to quality, not related to degradation. It's related to a process of oxygen concentration that is different to pair. So I think has, let's say, the first mover and the first adopters of mass production, we have faced one of those challenges, which is explaining, let's say, the differences between the effects. But always the message for us is we have tested, we know what is going on. And actually, Jinko is part of the ICID working groups to try to understand these defects or effects of the wafers and what should be the evaluation process that we believe have to be adapted for TOPCon. So now I will not reveal all the secrets. My message here is more to focus on what is Jinko a strategy of success. So Jinko from the R&D has a strong investment and a strong team. We actually at the cell level take care of the material characterization. We do several testing. We also have a process control. And I needed to mention here, even if it's not in the slide, Jinko have pilot lines that only belong to R&D before launching and mass production in all our factories worldwide. So that strong background is what motivates us to, let's say, discuss these topics with this technical background. This is just one of the examples that we do for analyzing, let's say, the where to improve, what are the deficiencies of a product now or of a technology now, and how we can improve for the mass production list. So I took the example of a publication of our record cell in 2021, and this is an analysis of optical and electrical losses. So what you can see here is how Jinko detects where are the areas of um, losses and what are the possible improvement. The left side is an external quantum efficiency analysis. We also do that electrically, meaning we analyze in what part of our complete block of, let's say, wafer we have the most of the losses. In this case, the boron diffuse region of the front surface was detected as the representative of most of the total losses. And this analysis that you can take a look in the paper allow us to establish really steps to achieving our mass production, let's say, efficiency. So we have a path, a clear path of what we would like to improve, starting from metal shading, moving to metal recombination, moving to the bulk enhancement, the resistivity optimization, in order to take the most of TOPCon technology. So this is when it comes to sale, and I have to be very honest. This is the slide that I like the most to strong also to show our strong portfolio when it comes to patents compared to all the competitors that are doing TOPCon. Jinko holds most of the international patents, also in China, of course. But this is also a sign of how much R&D is behind the products that Jinko brings to the market. And quality, of course, the production quality and maintaining the quality and overseas manufacturing is a challenge. But part of our process is to introduce at every single step quality control. We also hear the feedback of the market. So quality can not only be corrective, it's also preventive, and this is where Jinko have most of the let's say measurements taken to test before launching, before mass production, but also if there is a necessity, introduce correcting. And being a vertically integrated production allow us to be more flexible on that, let's say, processes. Finally, how we actually ensure success? Well, data and more data is how I call this slide. At the cell level, we have a strong investigation, a strong R&D where we use quokka simulation most of the time to detect our let's say weakness and also our advantages. But not only that, before doing any introduction, we also do our pilot testing of procedures. But this is R&D, and the other is the worldwide field test and the reality. So apart from all of our projects that we track very close with our clients, Jinko has also introduced testing centers worldwide. We work with different external partners to test our technology. So here are some of the tests that we are doing with our TOPCon technology compared to our PETA technology, spatial bifacial. We also have monofacial string, module level. Some of the colleagues that are going to be in the panel are also part of these test centers because we use the third parties to test. And this is how we collect also real data that we bring down to our improvements at the production. And it's not only about data, it's about testing. And of course, Jinko does internal testing, but not only. We rely on third parties, and I put one of the most, let's say, common one and received in the market, which is a PVEL scorecard. Here, our TOPCon technology was top performing again this year. So we are proud to say it's not only Jinko talking about quality, but third parties also corroborating our quality. And we went beyond our expectations of the IAC. So we tested 3 times the IAC reliability in different testing, dam heat, thermocyclone, humidity-free, PID, and both of our modules, monofacials and bifacial TOPCon, achieved without problems the IAC limits. So the reports are there when our clients have concerns about reliability or issues at the, let's say, production level, soldering. What we can say is, look, we have tested our products, we test always, and we can prove the quality of them, not from Jinko, but also from third parties. So I think this is what I wanted to share, and the conclusions we can discuss within the discussion. But the main message for the conclusions is, yeah, a strong R&D, prevention, of course, correction, and yeah, finally, also testing and reliability from third parties to prove the mass production quality of TOPCon.
Well, thank you, Johanna, Bonilla, for bringing us up to speed about the quality processes that go into the manufacturing of TOPCon modules at Jinko Solar and the various different product testing sites that you run around the world, and also including third-party testers. And to our audience, stay tuned for more on early adoption of TOPCon here on the main stage in just a minute. Thank you, Johanna, for being on our program today. Well, as we heard, there are pathways which manufacturers can choose to adopt TOPCon without taking too high of a technology risk. And while it seems this is news and the approaches to quality assurance built on the past and maybe also some mishaps, my next guest has been adopting TOPCon already years ago. It is my pleasure to introduce to you Lars Podlowski. He's the Chief Technical Officer of Solyco, Solyco Solar, a German module company. Lars brings to the table an unparalleled wealth of experience with a career spanning over 20 years in the PV industry. His journey includes significant roles such as serving as the Chief Technical Officer at the former German module manufacturer Willuhn, and he has also served as the Director of R&D at the crystalline solar segment of First Solar. And he has also co-founded the Photovoltaic Research Institute, PI Berlin. But the reason we're bringing him on our program today is that Solyco has made a move to adopt TOPCon in their modules back in 2020 already. Lars, as we explore this significant milestone, my first question to you is, have you just been willing to take a lot more risk than anybody else?
Yes, hello from my side to everyone. Actually, I'm not sure if we were taking a lot of risk. I think if you have the respective experience that I had with N-type solar cells and solar module technology, it's not so much about risk. I think you have to well understand new technologies if you want to be innovative, if you want to be a front runner. And of course, you have to test, you have to make your own test. We also work a lot with third-party institutes before we bring something onto the market on a commercial level. But then I would say the test, the risk is really limited if you understand what you are doing.
So let's go back a little bit. So why have you started using TOPCon in 2020?
Yeah, actually, my experience with some kind of TOPCon started much earlier. As you were explaining, I was working at First Solar back in 2015 and 2016, and First Solar with this small crystalline silicon group that they had at that time called TetraSun. That was actually one of the very first TOPCon products ever. And at that time already, we experienced the advantages of TOPCon, which is the better temperature coefficient, the better bifaciality coefficient. But at the same time, we were also experiencing the technical challenges related to TOPCon. So we were aware from the technical side what impact it has to use the right encapsulation material, not in terms of chemistry, also in terms, let's say, of thickness, for example, what impact the right backsheet can have to product reliability. So the experience with TOPCon started already back in 2014, and yeah, that's why we were very excited when actually TOPCon started to become a mass production technology then about 2020.
But then you say in your time at TetraSun or at First Solar, you already knew about the technical problems that can arise with the use of TOPCon cells. But in 2020, when you started to see it come to the market, weren't you afraid that there might be some of these problems actually? How did you ensure that there aren't?
Actually, before we really were launching a commercial product, of course, we also tested. And of course, we were aware about the risk for glass backsheet modules and for double glass modules. And that the risk for double glass modules, because their double glass structure better protects from moisture ingress, that double glass is a better technology. And that's actually by 2020, we started with offering a double glass module only. And all the recent testing that we were doing from various factories actually is showing that TOPCon used in a double glass structure is a very, very reliable and also very safe technology. There's not really significant risk involved. So that's why when we started back in 2020, we were choosing like a double glass structure, and that's why the risk was really very limited from the technical background, from the technical experience that we had at that time.
And have you stayed with that double glass structure, or are you moving on and also using transparent backsheets, for example?
No, we are not using transparent backsheets because we really think for bifacial application, you should use double glass. we are also offering like a glass backsheet version of the panels, but for glass backsheet, actually, we were quite slow in introducing that to the market because we were really aware of the challenges, and that's why we were intensively testing any kind of bill of material combination, and so it took us quite a long time to really introduce TOPCon glass backsheet to the market, just in order to be very, very safe that there's no risk involved for our customers.
So, and can you share with us the secret sauce when you look at the bill of material, or you send the bill of material to the manufacturers? What do you want to see in it? What's the decisive part?
So the decisive part is, of course, first is a chemistry. Are you using POE or using EVA or using EPE, which means a combination of EVA and POE? What material you're using at the front side, what material you're using at the back side. So these are really the most critical things. And I think because of our long experience, we really understand the impact and the influence of the chemistry, specifically on TOPCon.
And we heard just a minute ago from Johanna Bonilla that also the wafers have the metallization process of the wafers can lead to various resistance within the wafer or alongside the ingot. Is there something you can do to find out about that, and by looking at the BOM?
No, not really. So the wafer, as Johanna has just shown, you can see the wafer quality basically in EL image only, and that is not impacted really in the bill of material. I think the wafer is not the most critical thing for TOPCon. It's really the metallization, so which means the silver paste, the metallization paste, in combination with.
Oh no. That's a shame. I'm afraid we have lost Lars. Or Lars is back?
No.
Okay.
At least I can hear you.
You are back. Maybe you want to finish. We are at the end of our interview, but maybe you want to finish your sentence. You were speaking about, we lost you when you were speaking about the silver paste and the metallization.
Yeah, I think, sorry. The combination of how to do metallization in combination with what encapsulation material you are using for your module. This is really the most critical factor for the long-term reliability of the TOPCon product.
All right. Thank you, Lars. As I said, we are at the end of our interview. Thank you for taking the time to join us here on the program and share your knowledge and expertise with us. It was highly appreciated. And as we conclude this segment, we encourage you to stay on for more, because we're going to have a panel of experts. And thank you, Lars, for joining again. So yeah, join me. Stay tuned for a panel of experts that's going on here on the stage right now. So, as I said, we are welcoming a panel, and we are now moving towards the panel. And they have dedicated their entire careers to the quality, to ensuring quality in the solar industry. First, we have Jean-Nicolas Jaubert. He's the Director of China Affairs at PV Evolution Labs. Jean-Nicolas has extensive experience in certifications for solar thermal and photovoltaic products, having spent 13 years in reliability testing for a Tier 1 module manufacturer. Welcome, Jaubert.
Hello.
Hey. And joining him is also Jörg Althaus. He's the Director of CEA's Services, Engineering Services and Environmental and Social Governance in Europe. And Jörg is overseeing PV module and racking system quality. And before CEA, he spent a whopping 22 years at TÜV Rheinland, where one or two people watching might know him from, where he led the global solar business. Welcome, Jörg.
Hello, good morning, or good afternoon around the world. Very pleased to be here.
Christos Monokrosos has taken over as the global segment manager at TÜV Rheinland, and he specializes in the reliability and accelerated testing of photovoltaic modules. And also he looks back at over 12 years of experience in performance characterization of PV devices and other quality fields. Welcome, Christos.
Thank you so much.
And we also have Sandra Lust, a chemist with a PhD from the University of Paris-Saclay, joining us here on our panel. She is now a project manager at PI Berlin, and Sandra brings a rich history in the field of photovoltaics with her dating back to 1997, and where she also served in senior roles at Q-Cells. Welcome, Sandra.
Hello, nice to be here.
Well, my first question is also going to you, Sandra, as the quality report on TOPCon stemmed from your colleagues at PI Berlin. And we want to find out, with PERC cells, we are used to some acronyms like PID, LID, LETID. Looking now at TOPCon, should the industry learn some more or some new acronyms?
I think from the technology point of view, the problems you could observe with TOPCon, you are familiar with already. It's about PID. It's about the corrosion, possible corrosion of finger grids. It's the degradation of aluminum oxide. So it's not really new, but let's say the answers in this technology are new. Speaking about the encapsulants, so there are some challenges for quality control we are facing now.
Okay, and the quality, there are new challenges in terms of quality control for the encapsulants?
So first of all, what Lars already mentioned is that we get more and more class-class modules, which means that the very basic quick and dirty tests like the peel test to test the adhesion of the encapsulant, we cannot do any longer, no, because class-class. And you use new encapsulants, especially POE, where the old GIL content standard tests, they are not optimized for. The tests were made for EVA. And so we are a little bit lacking of standardized tests. And that's what we observe, that different labs measure different values. And this gets even more complicated when you now look at new material combination like EPE, or now you have EP, which is a double or triple layer of EVA and POE. So basically all you can do with this material is trust your encapsulant supplier and your model supplier that everything is okay. Or you do accelerated aging tests, but this takes a long time and it's costly.
Okay, maybe I play the question to Jean-Nicolas Jaubert from PVEL Labs. You are testing in your module scorecard hundreds of modules, I should assume. What are you seeing, and how are you testing for the encapsulant failures, for example?
Thanks, Marian. So actually, I think what Lars told us a few minutes ago is very true. Like we saw really two stages. Like 2 years ago, what most of the manufacturer were sending us as BOM were very conservative BOM, like double glass, POE, and so we are not seeing so much. Like BOM we tested 2 years ago, they were behaving quite well. Similar degradation in our thermal cycling, damp heat than what we were seeing in PERC. Maybe a few more of PID, like Sandra was mentioning, but very stable and reliable. But recently, I would say in the past 6 to 8 months, most probably because some cost pressure, we've seen people trying new type of BOM, new encapsulation scheme, a bit more of EPE, combination of POE and EVA, more risky combination, and we're really starting to see issues. And again, that's echoes quite well what Lars was saying. We're starting to see damp heat, delamination issues, cell to glass, encapsulation to glass or encapsulation to cells, and also thermal cycling issue, which are related to the metallization. So the choice of encapsulation, the choice of metallization paste and metallization scheme are becoming more risky, and we're starting to see really some interesting results recently.
But is it then that easy to say it's all about the type of encapsulant that you use, and all the modules that use EPE instead of POE will fail the test? Maybe I asked the question to Christos from TÜV Rheinland. Are you mute for a second now, Christos? We can't hear you. No. Unfortunately, we cannot hear you. I think I will play the question to Jörg Althaus, and I hope that our technicians can figure out the problem why we can't hear you.
Well, you know, first of all, I would say that there is a big push now for many people to move into the TOPCon, because the market would like to have that option to the reduced levelized cost of energy with the bifaciality gain, efficiency gain, but also in reduced degradation. And that is, of course, also meaning that if we hear to what Jinko was saying earlier, Johanna, and also Lars, there needs to be the research on the material, on the bit of materials. If you just have a manufacturer that buys a different cell and puts it in the same sandwich, that is likely going to have some issues. But none of it is totally new. And as Lars was putting it, if you know about the issues, then you can solve it. What we see in the industry now is there are still some learning curve ahead, and there is a wide spread between the different products. We see products that are performing better than the PERC already, but in the testing, batch testing that we perform on project level, we see also outliers that perform worse. Is it one manufacturer that is normally using the right combination of chemistry of the sandwich, as you call it, and sometimes for cost reasons cuts corners and then introduces one bad batch, essentially? Are you seeing that? Well, what we have to look at it at the moment, there is a huge increase in capacity at every manufacturer. Putting up new lines, new equipment with new people, sometimes in new countries, and that is beside the technology being used, causing quality issues. I think all the third parties see that with new production and the rapid ramp up, there are learning curves on the quality, and yield levels of production output are lower. Reject rates are higher, and also rework rates of modules that need to get fixed before they leave the door are increasing. That is not necessarily due to TOPCon being used. It is just a market situation where we're in at the moment. Okay. When it comes to TOPCon, I think we also need to see that also what Jinko was saying, we're still early, so the data that we all have is still very limited. Okay. We have Christos back, and we just heard from Sandra Lust that there are no or lacking international standards in terms of the encapsulant and the quality of the encapsulant, if I understood that right. I want to play the question to you, as you're well familiar with certifications and standards. Would you agree to that statement?
About encapsulants. Generally, IC 62788-1 will is pending publication and is addressing encapsulants. POE is used in TOPCon modules because it offers better corrosion resistance and also PID resistance. Perovskite modules may also employ TPOs. It's also a new encapsulant. Frankly speaking, I'm not the expert in encapsulants, but speaking with my colleagues and also with Dave Miller as a project leader in IEC and is addressing progress in standardization in encapsulant, there is a consensus that the current standards are adequate to assess the optical durability of encapsulants. So the test method is the same for those materials, which are all polyethylene-like, The discoloration for these materials, though, results from interactions between additives. Therefore, similar activation energy, I would say, is expected between EVA, POE, and TPO. However, the IEC group, I think, is now working to improve and validate the accelerating testing for adhesion of these materials, which is also very important. Generally, when you test for the adhesion, you want to test for damp heat and then do a peel test. And I think they're working to improve, optimize this test sequence. And I think they're also adding UV. Okay. Can you hear me? Will?
Yes, I can hear you, and I see Sandra definitely wants to say something.
Mm-hmm. Yeah, perhaps I have to add something. I'm not okay. So the IEC standard in this for the gear content was made for EVA and has to be optimized for POE, but this is somehow possible and because this is a cross-link material, so it's not a problem to fix this. But the Chinese use a different standard. They use their own national GP standard, and this is, to my knowledge, also used by the Indian photovoltaic industry. So they are using a different standard, and we have to be aware of that. And we see that results can differ, and we need to have their communication and check. And it's nice to have Jinko in this discussion and people who are working in China. So I think we have to get together and communicate and get some kind of real international standard, because it's not, doesn't help if we use the IEC standard, but the Chinese aren't any longer.
Jean-Nicolas Jaubert from PVEL works in China and is located in China. You know the standard?
Yeah, so I know where this standard. I use it in the past. I think I wanted to mention, I think Chris is right, but the IC group have developed standards, including, like he was mentioning, the delamination energy. But the use of this standard by the industry, there's a gap here. They are very nice standards, I think they're already effective to do such durability evaluation, but they are not used so well by the industry. So there's definitely, like Sandra was mentioning, a gap between what the industry is using and what has been done as standardization. But I think the standards are there already. They are very effective, the ones which have been developed in the past years.
And that is also the Chinese standard.
Could you please let me say something here? I'm also the project leader in IEC for 6.12.15. So the new version of IEC will require IEC 6.12.788-1-1. So that means that manufacturers, so long they want to get certification for the PV modules, will also have to certify the encapsulants. Thus, if this is coming in the new version of the IEC standard, it's not in the existing version, but it will come shortly. So I think this will address and basically it will force all companies to utilize the IEC standards.
And how do they have to certify the encapsulant then in this standard?
So this is, we're having a discussion. Maybe not the whole 62788 will be required, but some parts of it definitely they will be required.
We need to bring in some of the audience that are not so familiar with the numbers next to the standard. What does it include, the testing to get the certification according to that standard?
Like I mentioned, I'm not the expert in encapsulants, but generally they have a very long test sequence that combines damp heat with UV, damp heat, UV, and then you do a peel test in the end.
Okay. Jörg Althaus, please.
Well, maybe also in the interest of the audience, there's one thing about the encapsulants being certified. The other thing is about what is the manufacturer doing in the regular quality control during the production. And what is generally done is a test called the gel content test, which takes basically, you have to think of any encapsulant, not any, but the EVA and EPE and others, they cross-link. So under the lamination process, material really makes a bond, but there is some part of the material that doesn't, and that gets in this gel content that gets washed out, and then compared what is the remaining part that is really cross-linked, and that's a ratio. And what Sandra is referring to is that there are, in the inline quality control, tests being done on random samples, and the results compared to what test method is used can vary because of the way the test is being performed. And that is something, because that is not prescribed by any standard that anybody actually has to do this kind of testing. There may be also different manufacturers in different locations doing different testing. That is something that needs to be solved going forward. It has not been so much of an issue when everybody was basically using EVA, but now we have different encapsulates in the market and more need to use them. That is becoming a topic. But,
are you doing this test for the manufacturers as a third party?
Well, I mean, we can, on a batch level testing, we don't work for the manufacturers, we work for the buyers. Typically, what we would also do is to look at records of the manufacturers, what are they doing in their own reliability test laboratories, and witness the testing when we are on site.
And this is when you do the lab testing, the fab testing. Sorry, you go into the factory, and you see what types of quality testing they are doing there. And
sure.
And how often do you see that they're actually doing the Gale content test, as Sandra suggested it should be done, in let's say tier 1 manufacturers?
Yeah, so I mean, I think the topic of the different standards is rather new, and that's something we're currently discussing with the Chinese manufacturers in terms of the GB standard also being updated. But as we all know, standard development takes some time. So we definitely have taken that input to the manufacturers, and discussions are going on at the moment.
Okay. So the problem in general, we can say, is not inherent to TOPCon. There are ways to find out that TOPCon modules are also reliable. When they have the right material sandwich, and they have the right encapsulant and the correct Gale content, how reliable are they then? They are more reliable, or as reliable as PERC cells, maybe?
You're asking me?
Yeah, maybe I ask Sandra.
Okay.
I think there's no reason, if you use the right bomb, and this is a very important issue, to check the bomb. All of us agree on that point. But if you use a good bomb like class and POE, why shouldn't this module last for at least 30 years? There is no reason.
Okay.
May I please add something?
Yeah.
Okay. I think it's important to, first of all, study which are the new technology parameters that TOPCon modules introduce, because they also introduce several other innovations that we cannot overlook. For example, new PV module types introduce new interconnection patterns. We see solar cells having up to 18 buspers. They used to be 2. Like 20 years ago, 10 years ago, or 3, and now we have reached up to 18. New PV module architecture, such as half-cut, third-cut, and singled architecture they used for the past 5 years. We also, and new cell technologies, like, it's also not TOPCon, but also heterojunction and bank contact cells are being slowly introduced. But also they use larger wafers. On a module level, it's not only the cell size that's becoming better, but it's also the module. We see now modules exceeding 2.5 meters long. All these factors, coupled together with the new installation methods that we see in the field, often PV modules are employed on single-axis trackers, which allow plenty of room of things to go right or wrong. So specifically for TOPCon, I think we have to be aware of UAVID. So ultraviolet induced degradation. It's a failure mode that is related to hydrogen and the loss of passivation. And this is a saturating effect, but is also recoverable in high temperatures. Generally, we see modules having UVAD up to exceeding 5%, but we also see modules having up to 1% degradation. And I'm not going to go into encapsulants because I think we have only discussed about encapsulants today. I would also like to mention some other things. TOPCon modules are very capacitive. That means that they have so high hysteresis when you do the STC measurement. And this may introduce problems of the test house when you measure the power measurement. So the STC of the TOPCon modules is also an issue. In addition to this, I would like to say that TOPCon modules, as we have heard, majority of cases, they employ double glass because they want to have like a diffusion barrier for the water. And the double glass, PV module manufacturers to reduce cost as using thinner and thinner glass. Now we see glass that is thinner than 2 millimeters in the market, which is not tempered, and very thin glass cannot be tempered, can only be heat strengthened. And as the result, it has significantly less mechanical robustness. At the same time, we see large... Sorry, excuse me.
I can see Jean-Nicolas moving on his seat and wanting to jump in. I hand you the word right away. But there were many topics you addressed, and let's discuss them one by one, because I think it's very interesting. Maybe we can...
Let me finish my sentence.
Yeah.
So I would like to say that we see larger PV modules in size installed in the field, and generally also the mounting points in the trackers tend to shrink. We used to have 8 mounting points. Now we have only 4 mounting points. And these mounting points get shorter and shorter, tighter and tighter to reduce cost. And this introduces more torque on the PV modules. And we see a lot of glass failures in the field. And I think the glass failure is by far the most important problem that the PV community is facing right now. Thank you.
Okay, I think I saw Jean-Nicolas moving when we were speaking about the UV degradation. Did I see that right? Are we going to kick off there now?
Yeah, not necessarily about the UVID, but yeah, PVEL also believe the UVID is very important. I was mainly wanted to mention that all the issue that Chris has mentioned, they are more. So you need first to validate the design. That's what the PQP from PVEL is doing. We validate the BOM and the module design. Then you also need, you have, like Jörg and Sandra were mentioning, you need to have component level quality assessment and quality control. And then you have this third branch, we did not touch so much a bit of it. You also have variation in the production of all these modules, different factories. And so because so much factories are ramping up now, you have a lot of variation here. That's a lot of things what we see sometimes in the PQP. So you also need to have a testing, or what we call ORT, like ongoing reliability testing. You need to pull out modules from your line and to test them. For mechanical load, to check if your glass is good enough. For UVID, to say if your cells are the same and are behaving well. I think that's a third tripod of the quality evaluation each manufacturer will need to do. UVID is, just to quickly also rebound on the UVID, I don't think it's only a TOPCon issues. We have seen this in the past on PERC also. So it's again, that we discussed a bit earlier, it's as you ramp up a new technology, many people are doing different things, different design, different BOM, and you see a lot of variation there, but some can do very good products already.
Now you say something. We saw the shift from AL BSF cells to PERC cells also being introduced quite rapidly. And I was not part of the PV industry back then already. I joined a little bit later. But maybe, Jörg, I know you were. Maybe you can bring us back to the time when the shift from BSF to PERC was made, and what quality concerns arose back then, or not step by step which arose then, but how the atmosphere was in the industry, and if we saw similar concerns and how they were addressed, and how the situations compare to this change now.
Well, you know, I think the solar industry has short innovation cycles, and any change requires a thorough look at the change and research. And what we do see with TOPCon is that you know, we are also analyzing the data from the PV Magazine outdoor test field in Xi'an, and there we can see, even though it's very early, we can see some performance advantages in the energy yield, and that means also we see that from the demand, there is a push for TOPCon, and people want to have that reduction in levelized cost of energy. So we see manufacturers signing contracts early on for output where maybe there is not sufficient time to do thorough reliability testing. And all the points that Christos has mentioned, we have to put in perspective, regardless if it's TOPCon or PERC. Modules have gone bigger, current has gone higher, glass has gone thinner, everything all at once. So that is causing issues, and it's causing huge issues. I mean, the solar industry is used to having issues, unfortunately, and big quality issues. Think about AAA a few years back or whatever. The difference is now if manufacturers are moving to a different technology or multiple changes at once, the potential risk is much higher because just production capacity is so much higher. So if there is a serious issue, it's causing gigawatts easily. Definitely, I think the TOPCon issues related to that with encapsulation, so that's mostly understood. We can see that PID, LID, LETID all can be reduced on TOPCon, and the advantages are there on the energy yield, but there are many other changes happening in parallel. So the only thing that we feel that can solve this is testing in advance, but also making sure that in the production, the quality is maintained. And we have a huge pressure on cost for all the manufacturers. So if somebody's not looking at the quality, there are probably going to be some shortcuts taken because the pressure is very high.
So it is again a question of getting modules and products audited and looked on by companies like CEA or like PVEL or PVEL and TÜV, of course, to get the certification right and get the quality testing. And it's not so much a question of the technology itself. I have one question, maybe I send it to Sandra again here, about the UV degradation. It appears in the cells or in the modules in 1%, sometimes in 5%. Terms, and it has to do with hydrogen. Can you explain to us a little bit more what happens there and what manufacturers can do to contain the issue?
I shouldn't go into physics right now. No,
okay.
I would okay. Let's put it that way. You could reduce it, as far as I know, by encapsulants. I'm sorry. By putting additives, no, to cut off the short wavelengths of the light, and this is again an issue for long time stability. As far as I understood, it's connected to mechanisms in the aluminium oxide layer, and I'm not going to talk about the role of hydrogen in this right now.
Okay. I was hoping this is a chemistry issue. I wasn't aware it's a physics issue, but I think it was close enough. But then I want to get into what buyers and big project developers can really do. I mean, we are seeing that I think right now this year it's half of module capacity that's being built as TOPCon, and it is the type of modules that many project developers will get on the market right now. What can they really do to make sure that they're not buying bad modules that will have a reduced output in a few years' time? Jean-Nicolas, maybe you can give us a rundown.
I think they need to use all the tools we discussed today. Right? They need to first validate the BOM and the design through PQP testing, so an extensive reliability testing. Then they need to have quality control to make sure how the manufacturer is controlling the encapsulant and other materials. And then they probably need to do batch testing when they get the module out of the field because of so many variations for different factories. So there's not a one solution. You need to have everything combined together to be really efficient.
Okay. And Christos, when the new IEC test is or the new certificate is going to come that you mentioned earlier, will it be so good that once a module has it, the Jean-Nicolas test PQP module scorecard test will not be necessary anymore?
No. This is a different thing. We're talking about basic certification, which is based on 6.12.15 and 6.70.30 for performance and safety. Jean-Nicolas PQP is based on extended stress testing. So this is based on 6.3209. This is a different standard. They are covering different aspects. So the first is, let's say, a quick test that will ensure that modules do not have any, let me say, infant mortality issues or things that may come up in the first years of their lifetime. While the PQP is looking or the extended stress testing, or if you want to know, also in TÜV Rheinland, we have another test protocol which is similar. We call it extended bankability protocol. They are looking into the long-term reliability of PV modules, and so they are different things.
Okay, thank you very much. So IEC certificates and individual certificates by testing bodies, lab tests and field tests will remain an important issue as we're transitioning further and further with the technologies that are being deployed in the solar industry. Thank you so much for being on our panel today. Christos Monokossos of TÜV Rheinland, Sandra Lust of PI Berlin, and Jean-Nicolas Jaubert of PVEL, and Jörg Althaus of CEA. Thank you so much for your time today. It was very engaging to have you on the program.
Thank you, Marian.
Thank you.
What a journey we had today. We began with Johanna Bonilla, the technical product manager of Europe at Jinko Solar, who gave us an insight into how the company has been embracing TOPCon technology and how they are ensuring that the quality standards are being met. And following this, we had the discussion or the interview with Lars Podlowski, the Chief Technical Officer of Solyco, and how he has been using TOPCon technology since 2020, and he highlighted what he's doing to lower his individual risk. And it was all a matter of looking at the bill of materials. And eventually we had the discussion with the panel discussion that you just heard, where we discussed the importance of the bill of materials, encapsulant materials, and quality testing. As we wrap up the session, I want to extend my sincere gratitude to all participants for taking the time to come here on the stage today and be part of the debate. We hope you, our audience, found this insightful, and I urge you to stay tuned for more insightful sessions today. Coming up here will be another session on next generation cell technologies. Aside from TOPCon, we're also seeing heterojunction and back contacted cells entering the race alongside TOPCon for a top runner spot in the solar industry. So stay tuned for that.